Okay, what we'll do is we'll get started. Again, thank you all for coming. Really diverse group of individuals from around the world. We're very excited. And the intros took longer than we had planned for because of that. But so there'll be several portions of this particular hackathon workshop, and as example, like Osama asked how we can use this for dereplication. What we hope at the very end of this is not only that you learn how to make your own libraries of compounds that you know, but you can understand that it's useful almost immediately. So if you say that this tandem mass spectrum is this structure, you will be able to re-identify it in your own data, hopefully by the end of the day, at least by the end of the week. So that's kind of the goal, just trying to close the loop. If you put in effort today, you will save a lot of time tomorrow. So it's not only just us lecturing, but the vast majority of the time we've set aside for breakout rooms for us to actually help you and do hands-on so you become more familiar with the whole process. And ultimately, at the end of the day, we want you to be able to have both the knowledge as well as a deliverable, which, to me, that feels much better too. So they'll be broken up into several pieces and lectured by me, Alan, and Morgan. And then the four of us include, I guess, is Peter still? I don't know if Peter's still on. But people from the Dorstein lab, or actually anyone who is familiar, will be floating around and facilitating, actually helping you look through your own data and hopefully making that a real deliverable. So
I'm still on in case you need me.
I'm sorry?
I'm still on in case you need me, but I won't be here the whole time.
Okay, no, yeah. Peter's great as a supervisor and a mentor, but I don't know how good he is on hands-on and making libraries. So maybe that's.
Yeah, I'm not the best person for that.
Anyway, so I'll be going just a high-level overview from the Google Doc. I'll be going over how to add single MSMS spectra at one time from your own analysis. And so this is, if you had spent some time saying, look, this is this structure, it's this kind of lipid or this peptide or other small molecule, you can remember that and save all your, tens of minutes to hours worth of effort, as well as systems to help you do this in batches. So imagine that you ran tens, hundreds to thousands of standards. You don't want to go looking through your mass spec data to actually annotate that. How can we speed that up and make it a nice resource, not only for yourself, but for the community? But at the end of the day, let's all be selfish to a little bit. And you're making these libraries for you in order to save time. So hopefully that's motivating. A side effect is it benefits everybody else, but screw everybody else. So let me sharing my screen, and we'll get the show on the road. At the very beginning, are there any questions from you all? Okay. So the very first thing, again, is we'll be able to show you how you can add a single spectrum that its structure one at a time. But first, I want to, so this is kind of the objectives. But anyway, we'll get to that. We'll give you a little bit of background as to why you would even want to think about adding reference tandem mass spectra ever. So this assumes a little bit understanding of tandem mass spectrometry for small molecule analysis. But broadly, just very quickly, if you take a particular molecule, shove it in the mass spectrometer, and you acquire a tandem mass spectrum for it, you see the fragment, the daughter ions, and that'll give you some sort of a fingerprint for that structure. And it's assumed to be reproducible to, a first approximation. And so if you see the same tandem mass spectrum, you have some hint that it might be a structure you've seen before if it looks the same. So kind of historically, what has been done is you see a tandem mass spectrum in your data, and you don't know the structure. Maybe nobody's ever seen it before, nobody's ever annotated it before. you do some manual effort, whether it's on the computer or some orthogonal structural elucidation, and you come out with a structure. And so that takes a lot of time. So if you ever see that spectrum again, you hope that you never have to spend that time. I personally have never actually done this because I don't have the skills to, but this is what I'm told by especially the natural products community. And so the goal is for you to say, okay, I've spent this time. I want to save this spectrum into a spectral library along with the structure, so that next time I see the same tandem mass spectrum, I know exactly what it is, or at least close analog of what it is. And I don't have to waste the time trying to derive the structure de novo. So at the end of the day, all this will hopefully accelerate your research, but it won't solve your research. So that's kind of where we're kind of going with this. And so the idea is not only for one lab to generate a library or run a bunch of standards, but rather it's to have the entire community collectively crowdsource the annotation of tandem mass spectra. So the goal is for you to annotate molecules in your data that matter to your research project. And so we find that that's a way better method to start covering the chemical space that actually is relevant to people's research. And so just kind of historical context, GNPS, we started this 2013, and we started, and back then there were a few resources out there for the creation of spectral libraries, but since then, because of community efforts and other resources, libraries have grown tremendously. And so these days we've got about 150,000 reference MSMS spectra at GNPS, but it only annotates about 5% of the data. It's better than the 0.5% or so we were seeing back then, but we still got a long ways to go. And so again, kind of bringing it full circle, if you have a new spectrum in your data, which we call query here, you can match it against the library and see if there's any similarity between what's in the library and your spectrum. And if there is, then what you can see is you can propagate the annotation. So and so you know at least putatively what the structure could be. Any questions? Okay, let's make sure we're in good shape. Okay. Okay, so let's move on. So we'll actually go to the GNPS portion right now. Just a little bit of a hands-on, just kind of explore things. So if everybody could you all hop over to gnps.ucsd.edu, and we'll go from there. This is we've done these workshops in person, so it's very strange when I can't actually see people typing on the computers. So, but okay, so we're here. So fingers crossed that we're all here. It's the splash page with all this stuff going on. And so what we can do is now we'll scroll down. First of all, you need to log in. So if you have a GNPS account, go ahead and log in. If you don't, go ahead and register an account. It'll be, if you just went there for the first time today, you'll need to log in.
And it is a free account, and we promise no spam.
Well, there'll be a little spam. Well, there won't be any. It'll be from us, maybe. But cool. Good. Everybody logged in, made an account. As a side note, highly recommended to use password managers with long passwords, so they're more secure. So, and then you don't have to remember it. FYI, we get a lot of requests for kind of password resets. So, anyway, okay. Now that you've logged in, we want to go back to the splash page. And if you scroll down a little bit, you'll see this section called GNPS Spectral Library Knowledge Base. And so first, you can browse the libraries that you can see here on this left side, or you can start adding your own spectra here. So what we'll do is we'll click on Contribute and then Add Bronze. Just to give you a little bit of context here, there's different levels of what we deem quality or trustworthiness for these libraries. And so gold, generally, we require, first of all, it's restricted access, so not everybody can add it. But it's for reference compounds where you run the standards. So you know, and you bought it commercially, so you know exactly what the structure is. So going down the list, bronze is generally something a little bit more putative. But generally, we just kind of throw a lot of things in there at the bronze level. And so one of the questions that you might ask is, how can I trust anything? And so number one is everything is putative to begin with, but we have the provenance of where the data came from, including the person who uploaded it and the lab. So at least you can, if you suspect it's correct or incorrect, you can follow up with the original contributor, and hopefully it saves you time that way. So they might give you a hint at the right direction, but at the end of the day, it really comes down to doing due diligence on the annotations and putting into your own biological and experimental context to really make sense of it. So, but again, the gold level is usually reserved for pure reference standards that have been synthesized or purchased commercially. So anyway, go ahead and click on Add Bronze. And if you're logged in, you'll be taken to a form like this. So it's a lot of stuff to fill in. But this is the form where you can annotate one single spectrum at a time. And so the way in which you want to accomplish this is you actually have to give us spectra. And the format that the spectra will need to come there's three formats that we generally accept that are open formats. There's two we generally like a little more. So MZML or MZXML is what we generally recommend. And this is usually a full run on the mass spectrometer, whether it's LC or direct infusion, but it includes tens, hundreds to thousands of tandem mass spectra directly in the file.
Ming, is it
yes.
okay if we don't have the workflow tab?
Yes, yes, that's a great question. We actually, so this is a side point. As a normal user of GNPS, we actually hide that. People get super confused back in the day, so I was like, screw it, it's hidden, only admins see it. So yeah, totally fine, totally fine. It's kind of the Apple approach, I think. So whether it's better or for worse, but so MZML, again, MZML, MZXML, and we'll show you a little bit later on potentially some conversions, or you can ask us. We have some tools to help you convert, as well as the open source tool Proteo Wizard is free to download on Windows, and it does a fantastic job of conversion. And so we have some documentation on the recommended conversion strategies. And so if you convert to that, it might have hundreds of thousands of reference scan numbers referencing your MSMS in that file. So you'll have to actually go through the file and know the exact scan number that's the compound that and the tandem mass spectrum that's from your compound. So that's kind of external work that you can either do in your vendor software or free tools for exploring mass spectrometry data. So first things first, if you go ahead and click on Select Input Files, this will bring up a little pop-up so you can actually select some test data. So this will bring up a little pop-up right here. And then what we'll do is we'll actually import some public data. So those of you who've never used GNPS before, you'll be familiar with how to select files. And so kind of uploading your own files are a little bit out of scope for this workshop. And we have some decent documentation to cover that. But next will be you click on Share Files here. and you can import, you can type in this particular number, and this actually references an accession for a public data set. So if you type that in, it'll bring this public data set into your workspace so you can explore the files and select it for doing things. So once you've done that, click the import button. Unfortunately, hitting enter doesn't do it. So you have to hit the import button. And then once you are done, you can go back to this tab called Select Input Files. And so maybe I'm going a little quickly. So now that we're back here, what you can do is you can hit these little plus arrows for this particular data set. It should be, if you haven't imported too many, it should be up there near the top. You can explore all the files in this data set. So just as an example, within the CCMS peak directory, there are these MZML files. So these are pre-converted for you, but if it's your own data, you need to convert it yourself. So you can click on this. You click on that particular file, just click once. And then what you can do is click this button called Spectrum Files. And what you can see is that then it will be over here. It'll appear under the selected Spectrum files. So that's how you know it's selected. So you can do this, but the slides will be generally for reference for in the future if you want to do this. We won't actually have you submit anything, just because if you actually submit, it goes live. So it's kind of, yeah. Anyway, so when we're done, go ahead and click Finish Selection, and it'll close the pop-up. And now what you'll need to enter is you selected the actual file, but you'll also need to enter all this other basic required information, either as dropdowns or as free text. So ion source was it ESI, LC-ESI, direct infusion. I forget some of the other options, but it's in our documentation. Generally, what we expect here is ESI data. We're building out a few other resources, but here will be ESI. The instrument type, is a QTOF, is it an ion trap, an Orbi trap of some sort, a positive or negative, where did you actually get the molecule? Is it from a lysate, is it a crude mixture, or is it commercial standard? The PI and data collector, so that could be you or a colleague that actually collected the data. Additionally, the most important will be for you to specify the scan number so we know exactly which spectrum to pull out of your files, the compound name, the adduct. You can enter precursor MZ if you wish, to correct the value in the file. But if you enter 0, it'll just pull it directly from the file. So we'll go from there. Same kind of principle with charge. You can ignore this plotting section. That's going to be deprecated and going away. And there's also advanced annotation that includes structure, which we highly recommend, but is not required. And so that will go into detail. That's in the documentation. And then generally do not change this library selection area. That's kind of an advanced thing. So, and once you're done, just hit submit. And if you hit submit and it finds a spectrum and it annotates it, it generally takes like a minute or two to run. It will be live. So that means everybody can see it. If you do any other workflows like molecular networking or spectral library search at GNPS, it will be used right then and there. So, you know, that's nice, but it's also, you kind of play with fire sometimes. So anyway, that's generally what we're doing here. And one of the things, so entering that is kind of a pain in the butt. But one thing I wanted to show you just as a high level thing is that it's possible to actually annotate and pre-populate these forms if you're doing molecular networking at GNPS. So those of you who are familiar with that, if you're not familiar with that, we'll hold another workshop on what molecular networking is, how to use it for the community. But if you have done molecular networking, you'll see a view like this, and this is classical molecular networking. You can see there's a view called View All Clusters with ID, and it brings you to all the molecules in your particular data set. And if you have annotated, done a lot of work, you can click on this Add to Library button from this view, And then what it'll do is it'll give you the actual spectra in the MZML files. And then you can click annotate to GNPS again. And then it'll pre-populate two things, the spectrum files here and the scan number. Unfortunately, we can't actually divine the structure or who your PI and data collector are. But you can you don't have to actually do the manual work of entering both of these things. They're pre-selected. Go ahead and fill out the other information. So that's great. Hopefully that makes it easy. I got a private question about adding structures. So let me just back up a little bit and show you kind of live where that is really quick. So let me bring my browser over here. So again, if you'd say contribute, add to bronze, and this will bring up this tab. Under the advanced annotation section, there are the most relevant terms are smiles and inchy. And so these are two ways for you to describe a structure. And for those of you familiar with ChemDraw or tools like that, you should be able to export a drawn structure as IUPAC, as well as being able to export it as smiles or inchy. I personally don't know how to draw structures, but those, I think almost everybody else here in this chat does. So definitely ask somebody who's actually a chemist. But okay, so again, that's one way to pre-fill it. If you've run feature-based molecular networking, a very similar kind of interface with one less step. There's an annotated GNPS link here as well under the view all spectra with IDs. Again, it pre-populates the spectrum and the scan fields. So all you have to enter is the compound name. It at least removes some of the logistical problems, and it requires you to, put down what you're good at, the compound name. So that's it. Simple. Maybe I ran a little bit long. I apologize to Alan and Morgan. Let us know if you have any questions, both here, offline, at the forum, via email, or we host office hours on Monday at 2 p.m. Pacific time. And I know a lot of people have been coming to that. We're happy to answer questions in any of the forums, or if you're on Twitter, just tweet at us. And I think a lot of people will answer. So that's all. The slides are available. Any questions so far, or for that particular portion?
Yes, and thank you for showing this the workflow for the uploading the spectrum. I'm Hugo from the Switzerland and working in the Aquatic Research Institute. I have a question about this uploading the spectrum for the data. So you showed, I think, if I understood you correctly, is to upload one data site, right? For example, if I have 10 or 20 or 30 or many compounds or many data sites, if possible, I can do the bench mode. Then I don't need to click many times.
Yeah, exactly. So that's exactly what Morgan is going to talk about right now.
Okay, good.
So
thank you.
There's multiple things, and just as a historical context, we built both of these originally, and when we originally populated some reference compounds in 2013, 2014, I sure as hell was not going to upload one by one because we did several thousand. So it's definitely there. And Morgan is going to tell you a little about formats, the workflow, and general procedures on how to get batch uploads working. There's a validation step and things like that just to help you troubleshoot in case things did go wrong. So yeah. Anyway, any other questions?
Hemi. Sorry, thank you for sharing this with us. I have one question about the compound source part. And the slide 15.
Okay, let me bring it up on the actual website. So we'll do it live. So compound source, yes.
Yeah, and I saw your crude and isolated traces. So for the crude, does it mean the pure compounds isolate from the simple, or just the crude raw data?
Yeah, so this is a really good question. Broadly, we have some documentation describing the semantics of each of these terms. So let me pull that up. But broadly, this is kind of an area where it's a little bit kind of fuzzy, just because we had defined this kind of really early. So we didn't define this. Okay, so we generally define crude as if there's several, I believe when there's several molecules in your whatever you run on the mass spectrometer. So it's not purified. It's a mixture of multiple things. And so again, this comes from the natural product space. So because there's multiple compounds in there, there might be the potential of different isomers. So I think it kind of captures that it might be an isomer of the listed structure. So it gives a little bit more ambiguity, at least relative to you injected a single standard where you know the full structure and of the compound.
Okay, thank you.
Yeah.
Ming,
Yeah.
I got a question. It was not very clear for me when you on the share files and you try to tap the name of your import data share. Is it the name of the folder or the name of the file where the Spectra is?
So when you import, you mean the MSV number, this accession number?
Yeah.
So that number refers to an entire data set. So the concept of a data set is it can be a bunch of files. So anywhere from one, or it can be, yeah, it's a bunch of files with at least one file. So when you import it, you're importing essentially this giant folder, and then you have to navigate to choose a specific file within that big folder.
I see. Now, I've been trying to add either my folder or my file that I upload, but every time it doesn't work. So I don't know.
Oh, whenever you try to upload.
Yeah. When I try to import.
Okay. So let's just, so if you do, let me remove this. So maybe we'll do this in the breakout rooms. We can look this in the breakout rooms. But generally, yeah, these data sets that you import, it's public data that already exists. It's a folder of some sort, and then it should appear here, and then you can open it up and browse the actual folder structure. But if there's an issue, happy to take a look at it. We can just kind of share screens and figure that out.
Okay.
Any other questions? Okay, so I'm going to stop my share now and kick it over to Morgan.
Okay. Hi. Can you guys hear me?
Yeah.
Okay. And can you see the slides? Cool. Okay. All right, so I'm going to walk you guys through doing like a batch annotation upload, which is basically if you want to put multiple spectra into your as a library. So to do this, we actually have really great documentation on all of this to walk you through everything. I'm not doing a live demonstration right now because my computer is exceptionally slow over here. But basically, if you were to go to GNPS and click on the top, look, there's a documentation section. From there, if you click on Spectral libraries, which you can see on the side here, I don't know if you can see my mouse, but there's Spectral libraries, and then we have reference Spectral library batch annotation or batch edition.
Morgan, before you go on, make sure that is everybody that wants to follow her, are they able to find this page? Or is there anybody that didn't find it? If so, just indicate so in the text real quick, or say something.
Okay. Thanks, Peter. So I can actually, oh, good. Okay. I was going to say I can click on something, but Okay, so and also we can, if people have any difficulties following, where when we break out into each of the rooms and we go over questions, I can also go through this live to just walk anybody through if it's confusing. I also have links located on the slide, so this takes you to GNPS, and then this is taking to exactly this documentation that I'm showing here. So it's pretty thorough. Basically, what you need in order to create, oh, I see. Let me just pull the chat. Oh, okay, sorry. Ming's just showing a link. So basically what you need to be able to create a batch annotation is you'll need a template sheet, and you need your MZXML files that you're wanting to create your batch spectra with. So here we have a template spreadsheet that you can use. When you click on it, it'll take you to, it just is basically a TSV file that you have headers at the top. We have descriptions of what to fill out in the template sheet for all of those. But essentially the most specific ones that we'd want to see would be a file name for the MZXML file or MZML file that you're using. You want an associated compound name, and then you want your scan number for each of those files. This is a really large one, obviously, but you could do that for, ideally, like we use the batch annotation for at least, like, I would say 30 spectra or more, maybe even 50 spectra. But that's the most important key things to fill out in the annotation template sheet. Obviously, there's a lot of headers, but the most important, again, is the file name, a compound name, a scan name, and then if possible, if you have a structure associated, we would like you to input that as it's Inchi or Smiles that could be used. From there, once you have your annotation sheet completely filled out, there's a annotation sheet validator. So that's located in there's a link to it in our documentation, and that's called the batch validator. When you click on it, it would take you to, it would take you to this page where you can literally just drag and drop your TSV file. This is your annotation sheet that you filled out. You drop it in, and it would say either if you filled it out correctly, then it will tell you you passed. Beneath here, if you have any issues in your spreadsheet, it'll give you a string like list of things that need to be fixed. So once you have your annotation sheet validated, the next step would be in our documentation. There's obviously file uploads in GNPS that you need to do. So we have, again, Ming referenced, if you're a new user to GNPS and haven't learned how to input files, there's documentation that you can look at under Spectrum Upload that walks you through it. But basically, once your annotation sheet has been validated and you have all your Spectrum files, you would go to another, this is a second validator called the batch validator workflow, and it'll take you to this on GNPS right here. You'll input a title for whatever your library is, however you guys keep track. And then you're inputting your annotation sheet, the TSV file that you validated, into the annotation table section right here. And then you have your Spectrum files and your email. It's all pretty simple. You're running this to basically make sure that your scan numbers, like the scan numbers that you input in your annotation sheet, match up with the data that you're inputting. That's one of the issues that some users come across when trying to create their Spectral library. So this validator is like the final part. Once this is validated and then goes to completion, you would see basically it looks like this. It's done and the validation is good. So once you've completed this final step, you basically send it along to this email listed here at CCMS Web. It's actually me. And once you send this along, I usually ask people to include a title for their library and then a description describing what the Spectra is, like where it comes from, just some background on it. So this is just basically if you're wanting to add a large section of Spectra to create a library, and how we go through the validation process for the annotation sheet. and then also making sure that your data matches up with your annotation sheet. Does anybody have any questions?
Yeah, I do have a question about the file name. Does it have to be the same that the name you put for the analysis?
Wait, sorry, can you say the last bit?
On the spreadsheet, you need to put a file name.
Mm-hmm.
Is it the same that you use for the analysis?
Yes, it would be the same file that you used for the analysis. So that file that you found, that specific scan number for that specific compound needs to
Okay,
be.
great, thanks.
Any other questions? Okay. So if nobody has any other questions, we'll also be in separate rooms so I can walk people through if they have any other questions, but I'm gonna go ahead and stop sharing and pass it over to Alan.
Can everyone hear me? Awesome. So thank you all for attending. My component today is to kind of walk you through MSMS Chooser. Everyone can see my screen, correct? Okay, great. So MSMS Chooser is essentially a workflow within GNPS, and it kind of takes everything that we've talked about today as the start, and trying to generalize this to a point where it really is an entire process from where you have your chemical standards all the way up processing, how to collect the data, as well as how to process it on the end. So you don't actually have to go through individual files, look for scan numbers, look for that particular MS2. It kind of does the workflow, essentially does that hard work for you. And in the end, you basically spit out a table of what the software believes the MS2 corresponding to your chemical standards are, so that you can review it and basically push it live. So just a couple points about this. It's really developed on one single mass spectrometry platform, but there's no reason why a similar analog method can't be developed. And we definitely encourage people, if you're using this, to share those method files with us. So in approximately 2 hours, you can collect MSMS spectra in both negative and positive mode from 96 samples. We're using a 96 well plate. And we're doing that using a flow injection LCMS method, basically. And then to process the data takes about 2 minutes for one of these 96 well plates. So this is, the analog version of this would be basically you opening up every file, looking for the scan number, and I've seen a couple of comments in the chat about how to even do that. This kind of alleviates all those headaches and worries where using a standard template, basically, the software basically look for the chemical and its MSMS for you. So there's a couple steps, and I've tried to include as many links as possible to these different different workflows or different documentations in this PowerPoint slide, which is available on the Dropbox. Dropbox is the link is in the Google Doc that we shared and tweeted out. So that's kind of the background behind it. This is meant to be something that we can quickly and robustly push a lot of chemical standards through, and really only have to worry about reviewing the quality of the data in the end. And then if there's any other questions, there is a manuscript published. All the code is on GitHub, so you can look at that and feel free to make any suggestions or raise issues there, as well as the GNPS forum, which I highlighted in the chat. A great avenue to ask us questions. There's moderators assigned from the group every month, and we try to respond as quickly as possible. But the general overview of the steps here And this is what I was kind of talking about. This is really intended to be kind of a completely thought out package for you all to consume and really utilize. So we have suggested materials as well as procedures to prepare all these chemical standards that you have, as a way of really pushing a lot of things through the system. Again, this is something that could be adapted to your own particular needs and what materials you have. Here we're suggesting that you use 96 well plates, and it's just simply putting each chemical in a separate well, and then really keeping track of what chemical you put in each well. This is the hardest bit, actually. And to facilitate that, we have the MS Chooser template and sequence generator, which can be found via this link. I wonder if I can link directly. Oh, I need to share my screen. Okay, we'll go there in a second. But essentially, we provide a Google Sheet as a template, and kind of the information that Ming showed that you have to enter in that page manually, field by field, and what Morgan showed in the TSV file, where you have that same information, it's just in a row within the Excel sheet. This is very similar. It's in a Google Sheet, and it contains all that standard information, as well as some basic information like the well position, like A1, for example, 96 well plate. And if you're using a Q Exactive Vanquish system, we've built it out so it automatically generates all the sequence table and information that you need to run it. But it's even one step less in terms of having to do things where you can just basically upload that table to the instrument, make sure that it's ready to go, and submit the sequence. Again, this is something that we're happy, or I'm personally happy to adapt to different platforms if you end up developing this. And from there, the data acquisition. So again, this is built on a Vanquish Q Exactive platform. So those are thermo instruments, and it's a single flow. It's a single injection into a flow of solvent. So from the LC. So every sample, essentially, the auto sampler comes along, takes up a couple microliters of sample, injects it into a flow of 50% methanol, and then the mass spectrometer does its MS analysis, essentially. And then it just continuously does this, right? And that's what really makes it so fast. It completes the entire composite mode, switches all the instrument over automatically, and then completes the run and the analogous analysis in negative mode. So we provide some information about how the method is actually developed on our platform, which you can translate that to your own instrument. So we're just using methanol water with some formic acid. So it's the materials are readily available in any kind of LCMS lab, as well as the method files. So if you do have a Exactive platform, you can just drag and drop those method files. And then finally, we have the MS Chooser workflow, which is actually workflow in GNPS. I'll show you the screen of that. But essentially, we upload this template generator, which is analogous to the annotation table that Morgan was talking about, as well as you just select all the data that you generated using this method, and it automatically goes through and finds all the MS2. So I have a little bit more detail and just for your reference about each section and some kind of caveats, like you must convert the vendor format files. Sorry if you hear a baby in the background. You must convert the mass spectrometry vendor files to the open source files, and I have a link to the documentation here that gives you some information, as well as at least on the data processing. It's extremely important that you actually go through and look at the results and rationalize whether or not they make sense, as well as just generally checking the quality. And I understand there is no right answer here, and that's what makes it so difficult. But take some comfort in the fact that, you know, one of the nice features about GNPS is that it operates like a Wikipedia page, right? Anyone can edit these. So if you made a mistake incidentally, that can be changed by another user who comes along, and there's full provenance of all those changes. So all the edits are traceable and trackable, so we know what got changed when, if there's any issue. And
Alan, it's not only just mistakes, it's also when you have partial information, it's better to have that information in there and then in the future update it. And that's what we're seeing often a lot. When you may have, let's say in molecular networking, you find a spectrum is related to an annotation by 16 Dalton or 15.995, which is an oxygen. You can say that it's the oxygenated species of that. But then later on, when you establish the exact structure, you can upload the inchi or smiles.
That's correct. And I got a question. There was a question in the chat as well about uploading structures that you're maybe not 100% confident in. I would say upload it because it gives people the ability to basically check. And they may agree or disagree with that structure. And again, fully editable. No one's gonna criticize you for being incorrect. This is the point of the community getting at the correct answer eventually.
Even if the structure is mostly correct, it's still helpful for the end user. I mean, when we do matches against the metabolomic data sets, they're all putative anyway. And so if they become important, you need to verify it subsequently in different ways and do a deeper inspection anyway. So that's the important part.
Yep. And there's a couple slides for people who are interested in this next steps, as well as some test data that we can go over in the breakout section if people want to try the workflow. And just to show people what the let's see what the template looks like. See if I can share my screen real quickly. Probably a bunch of things. Can you see the template generator? Okay, awesome. So this is the sequence table generator. Essentially, this is the place where you have to fill out the information, and we actually have an info tab, so it tells you each column, what it really means, what the intention of it is, as well as some examples of things to fill out. As you go through here, they're common to all these library editions, single or batch, ion mode, ionization mode, the instrument, the library quality, which corresponds to that bronze, silver, gold. And where it differentiates from those is that you have this well position. You enter the compound name as eventually the name that will be used for the GNPS annotation. And then all the information that you can enter here is useful in filling it out, which is the molecular formula, the smiles, the inchi, Cas number, and all that. And from there, so this is the template that you would actually fill out. We automatically format it for you. So we tell you what the file names are and all the required information to run essentially the batch validator that Morgan talked about, upload. So you would download this and throw it in there, for example, the validation, as well as I mentioned the sequence generator. So this is for the QE method that we have here. Upon entering the information to the sample template, this would be automatically filled out, and you could just download that and upload it to the instrument. And there'll be additional tabs here once other systems come online for that. I just wanted to point that out to you all and where it lives. And finally, so again, there's links to this in the PowerPoint slides. You can find this on GNPS. But the function of this is basically you basically input a title. Again, that's for your own purpose and tracking what you're running. The Spectrum files, you literally, just as Ming showed with the pop-up, you can select all your files from that MSMS chooser run. To run an entire plate, you could just choose the entire plate. And then this annotation table is the equivalent of that. It's the downloaded table from the sequence table generator. And there's one parameter that you must set. The default is 10 part per million error. So this is something that you might have to adjust based on the instrument that you use to collect the data. For the Q Exactive, we're suggesting this. And in the paper, you can see that it worked quite well in automatically selecting the data. In the breakout session, I'm going to walk through basically the results page. but I'm happy to take any questions that anyone may have right now.
Hi, Alan. I have a couple of questions. So I acquired data for 93 compounds, microbial natural products, which are commercially available. And does this mean, but I acquired them in my own method. Does this mean I can't use MSMS Chooser? Another question I would like to ask also, if I have already I have some metadata from the vendor, but the structure and the molecular formula is for the salt form, but the data that I acquired was for the free form. Would this make a problem, or should I change it?
So, okay, two great questions. The answer to the first question, so although we didn't develop it to analyze any data, you can actually apply it. Sorry, my toddler's yelling at me. Sorry, hold on a sec.
So maybe I can answer this
Okay,
particular
sorry.
question. Oh,
Okay. I'm back. The challenges of working from home. It's awesome. I love my toddler. It's a lot of energy. I wish I had that much energy. So the answer to the question is whether or not you can analyze your data if it's not collected with MSMS Chooser. Simple answer is yes. If you were to fill out the template and go to the and download that standard formatted table and put it into the MSMS Chooser workflow with your data, it would go through and try to find scans that match that exact mass. So it's looking for scans. Sorry, there's F32 or F35 flying by. It's going to look for scans matching that exact mass. So the challenge there is it may not pick the right one. So with the flow injection method, because we're analyzing a single chemical standard, the likelihood of picking the right mass is very high. And we have tried it on data not collected with our standard method, and it does in fact work. So Morgan and Emily can actually probably talk to you a little bit more about their experience offline. But they did this on their bile acid standards, which were complex standards, and it really facilitated them getting the data into the database much faster than you would be able to do manually. And then the second question I think was like you bought like a salt form of, or you have a salt form of a chemical, and what you're really analyzing, I think what you're asking is like the free base, and so if you analyze something like dextromorphan, HBr, right?
Yes.
You detect the dextromorphan free base, right? So the structure that you should add is dextromorphan without the salt form, is what I would suggest. We should have a better system of handling that in GNPS, but that is not currently developed right now. My suggestion is use the free base.
Okay, thank you.
Yeah. Any other questions? I'm happy to talk more in the breakout sections too about if you want to, for example, try it on a couple of files of your own data. We can kind of walk through that.
Yeah, and just to clarify this about, especially if you don't use the flow injection method on your own, if you already have data where you ran several standards or one standard per run, there's a template that you can fill out that fills out all this extra stuff for like the Orbitrap that Alan showed. But there's one specific thing that it generates automatically, which is an input to MSMS Chooser. Essentially, it says this file has this structure in it. This LCMS run has this structure in it. That's kind of the meat of it. And so if you fill that out either using our template or you create that manually, it will work. Again, there's caveats, as Alan had mentioned, about, well, if there's multiple MSMS for a given structure that it found, how does it choose the best one? for us, we kind of choose the most intense precursor intensity. That's a heuristic that we use. But that'll hopefully save you time, and instead of manually combing through. We also search for several adduct forms of each structure and list those out. So hopefully that helps and remove some manual annotation. But again, as Alan said, you still, hopefully you will manually go through and visualize the spectra. If there's a simple like button that says view the MSMS. So at least you can spot check very quickly. It doesn't take everything out of your hands, but hopefully it just takes most of the annoying work out.
And actually, Ming, while we have people, I can just show them quickly the view spectrum button. I think that may be useful. So everyone can see my browser. Okay. So oh, this is the validator. Oops. Okay. So this is just one example of the MS chooser output. A lot of the outputs in molecular networking also have this. But for example, this is the results page. So you have the compound name, the mass, the structure gets drawn if you input inch and smiles. And then there's these buttons here that are kind of small, but if you click view spectrum, it actually shows you what the mass spectrum looks like, so that you can review basically the quality. If you hover over the peaks, you can see the masses and look to see if that matches your expectation. So, as well as cover, if you click the spectrum USI, so Ming can talk to you about this if there's any kind of questions. It's going to load.
Hopefully.
Okay. Well, we'll just ignore that. Essentially, if you click that button, you can get to another view where you can change the axes of that MSMS plot to further help you analyze the data. So maybe a little bit slow right now, given that a lot of people are using stuff on GNPS.
Yeah, any other questions before we kind of set breakout rooms and then we can answer more detailed on the ground questions?